In this video, I will show you how to integrate when you have exponential expressions like these. Here is the main memorized rule that you will need. The integral of e to the u du equals e to the u plus c. Basically, it doesn't change. So let's let u equal the exponent. That's the most common situation. So u equals 2x. In that case, u prime will equal 2. Making the substitution, we have e to the u. Instead of writing dx, we write du divided by u prime, which is 2. Let's move this 2 out in the front as a 1/2. So I'm just going to erase it and move it. So time for the memorized rule. So we will have e to the u plus c as the main integral, and we still have this 1/2 in the front. Let's go ahead and substitute 2x back in for u. So then we have 1/2 e to the 2x power plus c. So that's pretty easy. For number 9, letting u equal 2x would not be enough. The u prime will not cancel out what we need it to cancel out. So let's let u equal the entire denominator, which is pretty common. So we will let u equal 4 minus e to the 2x. That means that u prime will equal, I'm going to just leave the negative sign here. The derivative of e to the 2x is e to the 2x, but you have to do the chain rule and multiply by the derivative of the inner function. So we have to multiply by 2, which I will actually put in the front. So u prime is negative 2 e to the 2x power. Let's go ahead and make the substitution. So we have e to the 2x over u. Instead of writing dx, we will write du divided by u prime, which is negative 2 e to the 2x power. We notice that we have e to the 2x power in the numerator and the denominator. So these will cancel each other out. On the next step, we will have negative 1/2 in the front because of the negative 2 in the denominator. So let's write negative 1/2 and then the integral of 1 over u du. So we have learned another memorized rule, which is that the integral of 1 over u du is equal to the natural log of the absolute value of u plus c. So memorize this if you have not already done so. So I'm about to use that right now. So I have negative 1/2, and then here comes the memorized rule. Natural log of the absolute value of u plus c. Let's substitute 4 minus e to the 2x back in for u, and we will have negative 1/2 natural log absolute value of 4 minus e to the 2x and plus c. Okay, this is your final answer. Number 10. I see that we have a monomial in the denominator. So let's try rewriting this using the a plus b over c rule. We know we can rewrite this as a over c plus b over c. So what does that mean for this integral? We can rewrite this as 4 over e to the 2x power minus e to the 4x over e to the 2x dx. So let's do some simplification. So this will be the same thing as the integral of 4 e to the negative 2x power minus, when you divide like bases, you subtract the exponents. 4x minus 2x is 2x. So this will be e to the 2x power dx. I'm going to split these up into two separate integrals to make it more obvious what happens next. I'm going to do u substitution, but for the first one, I'm going to let u equal negative 2x. So u prime will equal negative 2. For the second integral, I'd like to do another u substitution, but this is going to be a different value, so I can't actually use the letter u. I need to pick a different variable. So how about v? So let's do a v substitution. Let's let v equal 2x, which means that v prime will equal 2. If we make these substitutions, we will have the integral of 4e to the u, and instead of dx, we will write du over u prime, which is negative 2. And then for the second one, we have the integral of e to the v, and I'm going to write dv over v prime, which is 2. 4 divided by negative 2 is negative 2. So I'm going to bring that negative 2 out in the front, and I have the integral of e to the u du minus. I see this 2 in the denominator. Let's bring that out in the front as a 1/2. So I have minus 1/2 integral of e to the v dv. So it's time for the memorized rule. The integral of e to the u doesn't change. So I'm still going to have the negative 2 and e to the u. And then moving on to the minus 1/2, the integral of e to the v is still e to the v. The only thing we need to add is the constant of integration. Now, let's put negative 2x back in for u. That gives us this. Now, let's substitute 2x back in for v. And this is the final answer.